Ohm's law is one of the most fundamental laws of electrical engineering. It gives us the relationship between voltage, current, and resistance. Let us understand Ohm's law through a simple experiment. Consider a conductor with some amount of resistance connected to a power source. Initially, the voltage applied across the conductor will be 6 volts. If we measure the value of current flowing in the circuit at this point, it will be 3 amperes. Let us increase the value of voltage applied from 6 volts to 9 volts. Now, there is a corresponding increase in the value of current from 3 amperes to 4.5 amperes. So, it is clear that when the voltage increases, the current in the circuit also increases. In both the cases, the resistance of the conductor is kept constant at 2 ohms. This is Ohm's law in action. Now, let us together define Ohm's law. Temperature being constant, the potential difference across the conductor is directly proportional to the current flowing through it. That is, V proportional to I. Let us introduce proportionality constant R. We get V is equal to IR, where V is the voltage, I is the current, and R is the resistance. When we plot a graph of voltage versus current, we get a straight line passing through the origin. The slope of this line gives us the resistance. Hence, voltage is directly proportional to current. Though Ohm's law is one of the most fundamental laws, it is applicable to only certain devices. These devices are called ohmic devices. As it is not applicable to all the devices, there are some limitations of Ohm's law. Let us go through them now. At first, Ohm's law cannot be applied for elements in unilateral networks such as diodes and transistors. They do not have same voltage-current relation for both the directions of current. Secondly, Ohm's law is not applicable for non-linear elements where the current is not exactly proportional to the applied voltage. This means the resistance of these elements change for different voltages. And third, it is not applicable to gaseous conductors. Finally, Ohm's law is valid for metal conductors only when the temperature and other physical parameters remain constant. This is about Ohm's law and its limitations. This is one of the most frequently asked questions in the exam, and you better know how to answer it. To sum up, in this video, we learnt about Ohm's law, which says voltage is directly proportional to current. We learnt about its application. And finally, we saw the limitations. In the next video, we'll learn about Kirchhoff's law. See you there.